Can I ask the speakers to open their video so it I can talk to you and people can see you? Yeah, as you see, Klaas, I will start with a question for you. You mentioned several reference sources, and the question was, will the links be available or are they included in the paper that you mentioned maybe?
Everything I showed is indeed included in the paper, so that's why I only mentioned the one. And well, in point 2, someone asked, where is the paper? And you can find it. It's open source, available on the site of Klima, their conference website.
So if someone wants to check it, of course, it's possible. I have a question for you, Douaa. The question is, which Modelica library is used here for the building simulations that you showed?
Okay, so we used a combination of 2 libraries, which is the IDS library, which was mainly used for the building components, and the buildings library was used specifically for to include mass flow sources of VOCs, because that was not possible in the IDS library. And I think there was one more question I saw in the Q&A. I think it was directed just to me. I don't know if you saw it as well.
No, can you read aloud the question and also answer it?
Yes. So what is the severity of the shock? Why is the severity of the shock differently defined for the 3 types of the hazards? Can the exposure during shock be used as basis for severity, leading to a uniform definition for all types of disruptive events? Yeah, okay. So for that, I would say that, the exposure of the occupants is an end result of the shock itself. So it's a manifestation of the resilience performance, which is why it was included in the resilience performance aspect assessment in the resilience effectiveness index. So for us, the shock is just a causality. So it's just a cause. So we want to relate it strictly to the events that cause it. And this will allow us later on to see the evolution of the resilience score as function of an increasing degree of shock. So we wanted to keep it separate. So the shock is really just the cause, and the quantification is related to the cause, and the consequence is basically manifested in the resilience score and the framework itself, so the different quantified aspects.
Okay. And it's also like for Klaas, you showed some published work, so maybe it's also good to include the link in the chat. So if someone wants to see the results more in detail, and we will also publish it later on, also on the website. Then for you, Zak, the question is here: does the optimized layout take into account the fire protection issues and sound level transfer?
For the first part of the question, does it take into account the fire protection issue? At the moment, no, it does not, but we can easily implement this into the method through imposing a constraint. So there will not be any issues attached there. For the second part of the question, which is the sound level transfer, yes, we do assess the sound levels within the method. However, for sizing the silencers, I added the I did not present it in this presentation, but I added a reference to the paper that we also developed a method for sizing the silencers for the ductwork system. I don't know if that answers the question.
I hope so. There is a second question for you. In the optimized design, the main ducts are no longer located in the corridors that we noticed, which would require specific sealing solutions in the rooms to hide the main ducts, leading to additional costs. Was this taken into account in your comparison?
Well, that's a very good question. From what we design here is the ductwork system. So that's the ducts and fittings in this methodology that I presented there. However, the additional cost, yes, there can be additional cost due to the silencers, and that actually was one of our conclusions that should we consider, for example, this additional cost at an earlier stage from the design, and we are still in the process of investigating this as well.
Mm-hmm. So I also think it's also about the solution. So, but I think it's a lowered ceiling in both cases. Huh? Or is it different? So yeah, the ceiling solution is the same if the ducts are in the central corridor or not. Eh?
Yes, indeed. Yeah. So
But you're right, indeed, the silencers can be different. Yeah.
Yeah, but having a full Indeed, just like you mentioned, indeed.
Yeah, so indeed 2 points for future work for you, I think.
Yeah.
Okay, and yours, there are several questions for you. The first one, you talked rapidly about electrostatic filters. Have you tested the durability of these filters in terms of performance over a year? And have you also checked byproducts?
Okay, so these types of electrostatic filters, if I can call them like that, they were also included in our test setup. So we followed them up for more than a year and we did monthly measurements of their efficiency. So we had two versions of these systems included in the test setup, one with a collector that is cleanable, that's a metal sheet collector, and another is a disposable collector. And we found that they have both a very high efficiency throughout a complete year, but for the one with the disposable collector, you need to replace this disposable collector regularly. So you need to do the maintenance to maintain the efficiency very high. Otherwise, it will decrease because the collector will get saturated. So that's an important point of attention for this technology. Regarding byproducts, we also looked at ozone formation because this is one of the risks of electrostatic precipitation, but manufacturers are well aware of this and they also use positive charging of particles. This means that it also will reduce the risk of ozone formation. And we measured it and it's quite limited, the formation of ozone for the two test systems we've tested.
Sounds good. And then about the residential air handling units with heat recovery systems, they typically have filter holders in place. Are they not suitable for fine filters is the question.
Yes, effectively residential systems are by default equipped with filters, either a coarse filter or a fine filter. We also tested these types of filters in our test setup, but we've noticed, especially for fine filters, that are less effective than the ones we've tested in additional filter boxes. And the pressure buildup is much, much quicker on these default filters than on the ones in additional filter boxes. And a third argument in that is that in a residential system, it's not possible to place two filters on the supply air, for example. So you cannot protect this fine filter by a coarse filter. So therefore, you always have to add an additional filter box. And that's the reason why we suggest to put the coarse filter, the default coarse filter, into the system and a fine filter behind the ventilation system.
Okay, that's clear. And then another question, do you have the cost and pressure drop growth rate for each filter setup? And do you use manufacturer recommended pressure drops for filter replacement?
We have an evolution of the pressure drop. I didn't present it today. We effectively have it, but we didn't recalculate it to a cost. And effectively, we see that after some time, we have a too high pressure drop, so we should replace the filter. But from a scientific perspective, we went a little bit further, but effectively for some filters, we can say for this situation, you need to replace the filter after 6 months, for example. For another, it might be after a year. For example, back filters, there you should replace them after a year, while folded panel filters, they should be replaced every 6 months approximately. But also, one thing I didn't mention, we also tested to clean these filters, and also cleaning can aid to prolong the lifetime of a filter. You don't affect the efficiency of the filter, but you reduce again the pressure drop. So cleaning regularly these filters can also aid to extend their lifetime.
Are these data in the paper in the AIVC conference of last year that you mentioned?
Yes, these results are in the AIVC paper.
Okay. And then the last question to you, would you prefer single stage filtration or two stage or even more stage filtration? And what about cost and IQ?
If I look at the situation, if you have the place, you can put an F7 back filter in front of the system. That's an interesting solution, and it's also cost effective because you don't need to replace this type of filter often. So that's also an argument, but it depends on the space you have in front of the system, and it also for air handling units depends whether it's possible to install an F7 back filter in front of the heat exchange. It's not always possible, so you have to choose the solution that it's in link with the possibilities in your system.
Mm-hmm. And there is a new question popping up for you. How are filters cleaned? And the person who asked it, I've seen too many filters cleaned with compressed air.
What we did is we used an aspirator to aspirate both sides of the filter, and we flushed them with compressed air, but from a considerable distance and not directly in front of the filter, and then ended up with again aspirating the filter and replacing it into the ventilation system. But of course, damaging the filter is a very important point of attention. If you see that the filter doesn't support cleaning, it might be better to replace it.
Okay. And then a question to Klaas and Douaa regarding the filters. Have you included differences between filter performances in your economic indicator, Klaas? I will start with you.
So the indicator, well, it's not in the indicator itself, of course, but if you do a prediction of air quality there in the models, you can of course include filter efficiency in those models. And I didn't show it in the presentation today, but we also did some variations where we include, well, where I did for the same building in Antwerp, did simulations with and without filters and quantified the impact there. So the results are available, but not in the paper.
Yeah. But with filters, it was not. There were no different performance classes for one filter. It was with or without filters.
No, there it was indeed with or without. Indeed. Yes.
Yeah, but as you explained in the beginning, the indicator is a framework, so you can easily add some things.
Yeah.
And for Douaa, did you check for resilience? You just
Yeah.
said with and without filters. Was it with filters with one performance class or more?
So what we now did was we tested the status quo of the building. So the current filters that are currently installed, which was a G4 pre-filter and an F7 filter for fine particles, which is what was already installed there. And so what we basically did is just we removed those filters and see what happens. But for future work, of course, we would like to test different filters with different performance and see how they vary. Probably we will see most of the results differences when it comes to outdoor pollution shocks and the results. Yeah, I didn't show the results for the resilience score, but it will vary between between CAV. It will be between the resilience score of CAV for an outdoor shock and that for DCV without for a DCV without filter. So it will be bounded between the two.
Oh.
That's what I expect.
Yeah. And Joris, a person asked about your guidelines. What is the most optimized setup to reach supply level 2 and outdoor class 3?
Yeah, it's a question regarding a standard that's using a system to determine in function of the outdoor air quality, that's the ODA, and the supply air quality to which filter you should use. But by heart, I can't answer this question directly, but you also need to consider that the supply air classes are defined and outdoor air classes are also defined in link with the WHO guidelines. So supply 2 is a fraction of the considered outdoor air guideline. But if needed, I can answer these questions afterwards written.
Yes, yeah. For the one who asked this question, it can be answered by email. We have your email address, so Joris can answer your question. Because indeed, it's difficult to know by heart. So.
Yeah, indeed.